to the third and final method of generation of ultrasonic waves, which is piezoelectric method. This is pretty simple, and the circuit diagram you will see is quite similar to magnetostriction. So again, before going into the circuit diagram, we'll understand what is piezoelectric effect. So you have certain materials which exhibit this property called piezoelectricity. Just like you have certain materials which exhibit the property of magnetism, only those are attracted by magnet. You have certain materials which exhibit a property called piezoelectricity, and with such materials what happens is you apply mechanical stress on opposite faces of that material, then there will be an electrical field developed on another pair of opposite faces. So for example, just give me a minute, I'm looking for some cube or something. Okay, let's assume this this notebook here. It's a very toy example. I don't know if you guys are able to see, but yeah. So let's assume this is a cuboid, a piezoelectric cuboid, and I am applying force on these two sides, these two sides of the notebook. I am applying mechanical stress, meaning I am compressing it. Then what happens is the opposite faces which are perpendicular to this side, meaning the upper and lower side, an electrical field will be developed. If such a property is shown by a material, it is called a piezoelectric material, and this property is called piezoelectric effect, meaning as long as you apply force to two opposite faces, the perpendicular opposite faces will show an electric field. And what is the inverse piezoelectric effect is, if you apply electricity to two opposite faces, then the perpendicular faces will either get compressed or expanded. So we use the inverse piezoelectric effect to generate ultrasonic waves. How? We take a piezoelectric material, we apply electricity to two faces. The other two opposite faces, they will either expand or compress. In any case, they will vibrate the air column surrounding them, and that vibration leads to ultrasound generation. Essentially what we are looking at is different ways of vibrating the air column. So this is one of them. So this is an example of piezoelectric crystal. You need to cut the crystal in a certain way that there is maximum space for applying force or electricity. So there are different ways of cutting. When you cut along the vertices, it is called cutting along the electrical axis, and when you cut along the midpoints of the vertices, it is called cutting along the mechanical axis. So how you cut makes a difference, because if you are cutting along a certain axis, you will have more area to provide electricity and less area for the force, the expansion compression to take place. If you are cutting along the opposite axis, it will be vice versa. You don't need to know which is which, just need to know that there are two things, electrical and mechanical axis.